Have you ever looked up at the night sky and wondered what the deal is with the moon? I mean, one night it's this big, bright circle, and then a little while later it's just gone. Well, let's get into it because this whole celestial dance isn't just pretty to look at, it's actually the reason we have things like weeks and months. It's the foundation of time itself.
So, to unpack all of this, let's start with a story. Picture this. A girl named Mira is at this amazing kite festival. The sky is just packed with color. The sun is out, and everything's buzzing. And then she looks up and sees it, the moon, just a pale little sliver hanging out in the bright blue sky. And she thought, wait a minute, isn't the moon supposed to be a nighttime thing?
And that got her thinking. And maybe you've wondered this too. Why can we see the moon when the sun is up? And for that matter, why does its shape change night after night? It's a great question. Okay, let's tackle Mira's first mystery, a moon in the daylight. To really get our heads around that, we have to understand one very, very important fact about the moon. Here's the secret. The moon is not a light bulb. It's more like a giant, dusty mirror hanging in space. The glow we see isn't coming from the moon. It's just sunlight bouncing off its surface. So yeah, if it's in the right spot in the sky and the sun's light is hitting it, of course we can see it during the day. But that still doesn't explain the whole shape-shifting thing. Right, so the moon's a big reflector. That solves the daylight mystery. But the changing shape? To understand that, we have to decode the phases of the moon. And before we do anything else, we need to bust a really common myth. Let's get this out of the way right now. A lot of us were taught that the phases are caused by the Earth's shadow covering up the moon. That is totally wrong. When the Earth's shadow does fall on the moon, that's a special event called a lunar eclipse. It's cool, but it's not what's happening every single month. The real reason is actually much simpler, and it's all about our point of view. The moon is always a sphere, and half of it is always lit by the sun. The phases are just us, here on Earth, seeing different amounts of that sunlit half as the moon makes its monthly trip around our planet. The moon isn't changing, our perspective is. So let's start at the beginning, the new moon. This is when the moon is passing between the Earth and the sun. From where we're standing, the bright, sunlit side is facing completely away from us. We're looking at its dark side, so it basically vanishes from our sky. Now, right after the new moon, we get into what's called the waxing period. Waxing is just a fancy word for growing or getting bigger. For about 2 weeks, night after night, we see a little more of that bright sunlit side. It goes from a tiny sliver to a half moon and keeps on growing. And you can probably guess what happens next. The opposite of waxing is waning. Once the moon hits its peak brightness, it starts to wane or look like it's shrinking. For the next 2 weeks, the bright part gets smaller and smaller until we're right back at the new moon again. So a really easy way to remember it is waxing means it's getting brighter and building up to a full moon. Waning means it's getting dimmer and fading back to a new moon. It's this simple, constant back and forth rhythm. The peak of that whole cycle, the grand finale of the waxing period, is the full moon. Now the alignment has flipped. The Earth is sitting right between the sun and the moon. This lets us see the entire half of the moon that's lit up by the sun. We get that perfect, brilliant circle in the sky. And this whole performance, from one full moon all the way through the cycle to the next full moon, takes about 29.5 days. It's this incredibly reliable rhythm that our ancestors noticed thousands and thousands of years ago. But there's still another piece of the puzzle. It's not just the moon's shape that changes. Its schedule changes too. It doesn't show up at the same time every night. Get this. Each day, the moon rises about 50 minutes later than it did the day before. So why is it always running late? Okay, think of it like a race. The Earth spins on its axis once every 24 hours. That's our day. But while we're doing that one full spin, the moon has also been moving along in its orbit around us. So for the Earth to catch up and see the moon in the same part of the sky, it has to rotate just a little bit extra. And that extra bit of rotation takes, you guessed it, about 50 minutes. So what do we have? We've got these incredibly predictable cycles, the changing phases, the shifting schedule. And when ancient people looked up and noticed these reliable patterns, they realized they had something truly amazing. They had a clock, the original clock. And this, right here, is the biggest takeaway.
Our most basic units of how we measure time, the day, the month, the year, they aren't just random ideas we came up with. They are a gift from the cosmos, based entirely on the predictable movements of our planet and its moon.
Let's just break down how elegant this cosmic clock is. One full spin of the Earth on its axis, that gives us the day. The complete cycle of the moon's phases, from new to full and back again, that gives us the month. And one full trip of the Earth all the way around the sun, that gives us the year. It's that simple and it's that incredible.
Now, once you have these units of time, you obviously need a way to keep track of them all, and that is exactly where calendars come from.
Throughout history, people have basically made calendars based on one of two things. You have lunar calendars, which follow 12 cycles of the moon, and you have solar calendars, which follow the Earth's long journey around the sun. The only problem is, they don't quite line up.
And here's the mathematical hiccup. A lunar year, that's 12 moon cycles, comes out to about 354 days. But a solar year, the time it takes for Earth to circle the sun, which controls our seasons, is 365 days. That 11-day gap might not seem like much, but it's a huge deal. It means if you use a purely lunar calendar, the seasons would start drifting, and summer might eventually show up in December.
So how do we solve this? Well, the solar calendar, which is what most of the world uses today, has a really clever little fix. We know that the Earth actually takes about 365 times and a quarter days to orbit the sun. So to deal with that pesky quarter of a day, we just bundle them up. Every 4 years, we add one extra day to the calendar. We call it a leap year. It's a brilliant little hack that keeps our calendar perfectly locked in with the seasons. So from a simple question about seeing the moon during the day, we end up here, discovering that our clocks, our calendars, our entire sense of organized time is literally written in the stars. And it really makes you wonder, doesn't it? What other parts of our high-tech, modern world are still being guided by these deep, ancient, natural rhythms?